Hi, this is my video number 22. So in this video I'll talk on the Liapunov method. Yeah. Liapunov direct method. So what is the Liapunov direct method? It's a method to study the stability of the solution of the system that we have dealt earlier. Yeah. So we consider, so the purpose of this is to study the stability of the solution of system that we studied earlier. Yeah, system of autonomous system. Now let's consider this system. X dot equal to f tx, where x is a unknown vector function, where x is x1 of t, xn of t. This is unknown vector function. So let's call this equation number 1. Now you can consider in more specific case, you may consider this as a x dot equal to f xy and y dot is equal to g xy. This is more a specific case. In this case, your x here, your x is f and g. Yeah, so we will study this using what we call as a Liapunov method or Liapunov direct method, which in this method, Liapunov direct method, let me call the LDM, Liapunov direct method. So it's really depend on the ability to construct a particular function, the ability to construct a particular type of function Let's call that function as v, a function of vx, from which the stability or instability, stability or instability of the solution can be determined. Okay, so let us first we assume that function on the right hand side f x tx, which is this is the set of function or vector function t, x, f and tx satisfies the following condition. F tx is defined. F tx is defined and continuous in region D. defined and continuous in region D, which contain all point x, such that a norm of x less than some number a for R1 T infinity. Okay, and second condition, the uniqueness of the solution, x t naught x naught of our system 1, this system, is satisfied. Is satisfied at every point t naught x naught in D. And third condition, that f t0 is equal to 0 for all t, and hence x t naught 0 is a solution for system 1 for all t naught greater than some number R1. Okay, so in order to study the Liapunov function or Liapunov direct method, we need to define some terms that needed to use in the process. Okay, so first definition I give here, the function the class K consists of all function, all continuous value, all continuous real value, all continuous real value strictly increasing function, phi r for r between 0 and a in that interval, which vanish at r equal to 0. So what does mean here? This means that this is our function phi r. So at r equal to 0, which means we have phi 0 is equal to 0. Vanish at r equal to 0. So all function which having these properties contained in the class of K, or class K consists of that function. Okay, we have a continuous strictly increasing function and also satisfy that phi not equal to 0. So that's the first definition. The second definition is that so the function v tx that we mentioned earlier is, we call it as a positive definite, is positive definite. Positive definite or negative definite. Negative definite. If there exists a function phi in K such that V Tx greater than phi mod norm of x, or V Tx less than or equal to negative of phi norm of x. Yeah, for all Tx in D. Now what does this mean? So it means that because phi is a function of function in K which satisfy all this. Yeah, the function phi is continuous, real valued and strictly increasing, and as well as phi 0 is 0. So which means if we consider 0, 0 as a critical point, yeah, if 0, 0 is a critical point, so the first condition to have either positive or negative definites, yeah, V T0 must be 0, because at 0, x0, that part is 0, so everything is 0 here. The same thing is on the right side. And we call positive definites if V, yeah, this is positive definite, if V positive, and the other one is negative definite if V negative. So it satisfies this thing. All right, let's see some example. Yeah? Let's see some example. If you have this function, if you consider this function x4 plus y4, yeah? This is positive definite. Yeah? This is positive definite. Why? Because if we consider 0, 0 as the critical points, definitely V0, 0 is 0. That's 0. And also Vxy is, so if you consider in polar coordinate, for this case as r cos theta, x r cos theta, y r sin theta, so definitely this part here is greater than half of r to 4. Yeah, because from here we can have r squared is x squared plus y squared. So if so we have r4, basically this is x4 plus y4 plus 2x squared y squared. So definitely this is bigger than that number. I mean that function. So where in this case r is r squared, or r is square root, or r squared is x squared plus y squared. So if you look at this example with that definition, so in this case we can find phi, which is in this case half, and our norm of x is given as r squared. So we have a function greater than phi x. So we have function greater than half of R4. So to get familiar with, so I would suggest you try this couple of simple exercise. Let's say v xy, y squared over 2 plus x squared over 2 minus x4 over 4. Number 2, let's say v xy is y squared over 2 plus 1 minus cos x. Number 3, if you have v xy is y squared over 2 plus x squared over 2 minus x5 over 5. Now determine whether this function is positive definite or negative definite, or even might not contain in both of them. Okay. So the second example, this is the first example. The second example, we may consider this function at v t x y as t x squared plus y squared minus 2 xy cos t. This is also positive definite. Yeah, positive definite for t greater than equal to 2. Since, of course, you can write this as v t xy is greater than equal to r squared. You can check those things. Yeah, greater than r squared. So in this case, our phi is 1, and this is our norm of r, norm of x. Okay, I would like to give you I think more clearer way of looking positive and negative definite. But before that, let me give you another definition. Which is the function v tx is said to be decreasing or to have an infinitesimal upper bound if to be decreasing or to have an infinitesimal upper bound if we can find a number h, positive, and a function phi in k. You know what class k is? Yeah, a class function. A class k is consists of function that continuous and steadily increasing, and with the properties that at the critical point is 0, such that the magnitude of that function tx less than or equal to phi norm of x for x less than h, for x less than h, and t greater than T naught. So if we consider the previous two examples that I gave just now, both functions are decreasants. Yeah, in the previous example, both functions are decreasant. For both example given earlier, both are decreasant. Where our phi, in that case, for the first case we have our phi is r to 4, and the second case our phi r is 3r squared. Okay, now let me define the liapunov function. Okay, define liapunov function. A function v tx is called a liapunov function if the following conditions are satisfied. If the following conditions are satisfied, number one, we have v tx is a scalar function and well defined, in D, yeah, for all t positive. And condition 2, we have v tx is positive definite and decreasant. Condition 3, we have v tx has continuous first partial derivative. Yeah, continuous first partial derivative. So which means if you differentiate with respect to t, we differentiate with respect to each x, all those are continuous. And condition number 4, we have v 0t equal to t for all t positive. And condition number 5, the derivative v dot tx is semi-definite. Semi-negative definite is semi-negative definite. Where v dot, yeah, you can consider v dot as x dot grad v plus dv dt, del v del t, and x is given as at the beginning of my lecture here. Now, what is this? I think you should know this thing. Yeah, you should know this. This, because we differentiate that with respect to t, and v is a function of x. Each x also depends on t. So basically, if you consider v is a function of x and y, and x is a function of t, y is a function of t, then what we have, our v dot is actually del v del x dx dt plus del v del y dy dt plus we have del v dt. Okay, and if you consider the specific function that I mentioned earlier, where our x dot, if we take as a f x of y, y dot is g xs of y. So we can see here, this just equal to del v del x dx dt is our f plus del v del t and y del y dt is our g, and plus those dv dt. I think yeah, dv dt. Okay, so this is the meaning of those things. Now, for the autonomous system, the scalar function v, normally the scalar function v we use, and vx has a continuous first partial derivative, which is del v del x is continuous, and also we have v is a positive definite, and v dot is semi-negative definite. Okay, so let me write it here. For the autonomous system, the scalar function, v is we use v as a scalar function, v dx, a scalar function. So without t is used, and v x has continuous first partial derivative, and v dot vx is positive definite, and v dot x is semi-negative definite. Okay, where our v dot is given earlier, so v dot, because this function is not dependent on t, so means our v dot is just x dot grad v, so which means we only have del v del x dx dt plus del v del y dy dt. For the autonomous function, for the autonomous system, the system that not depend on t. Okay, so this is the liapunov function. Of course, before we go detail on the example and so on, we need to develop some theorem. But before that, let me give you I think probably the much easier way to understand the what is the positive definite and so on. I think my time is already come to the end, so let me stop here. Then I will give in the next video, just in the next video I'll give a very short video just explaining in different view what we mean by positive definite, negative definite, semi-definite, and so on. So hopefully with that you can understand better. All right, for the time being I stop here. Bye.